Dear colleagues, we were going to make the balancing with the vibration analyzer DC23, and also for the balancing we will need some tools. One of the tools is scales to measure the balancing weights, and some tools to install this. So we have an installation setup. For the installation setup we have a vibration analyzer, we have installed the tacho probe. The tacho probe has the mark here. We have two sensors, two accelerometers that we will use for vibration measurements. So let's start. Initially we have done some diagnostics. We have found that it is N-balance, we have measured autospectra. Also we have measured close down of the machine to find the best location for the trial weight. This is also quite important. See the previous video how we did it. Now we go to the data collector, to the application menu, and in the application menu we go to the balancing program, like this. In the balancing program we set up our machine. So first of all we will need to enter the name of the machine. So this is an empty screen, and we use button 7. This is to create a new machine. So we press button 7. Machine name, you can press enter to get the cursor here and edit this name. For example, here I can say that this is name 3. Let it be just name 3. I press enter once again, and this is my name. Correction planes. How many correction planes I have on this machine? This is the planes where you can apply the trial weights and balancing weights. So on my machine I have two, one and the second. So I select that this will be 2 correction planes. Actually here, if I press enter, I see the list. In the DC23 vibration analyzer you can have up to 4 balancing planes, but here I have 2, so let it be 2. I can give them names. So for example, this can be mass 1 and mass 2. You can also press enter and enter from the keypad. As previously you did it with the SMS on the cell phone, you can enter the names. To finish it, press enter once again. So these are the names of the planes, mass 1 and mass 2. Then the number of measurement points. The number of measurement points, you also look at your machine, and here I have 2 bearings. We do the measurements on the bearings. So this is bearing 1, this is bearing 1, this is bearing 2. So I have the 2 bearings, and I enter here is the 2 measurement points. So also, if I press enter, you see that I can have up to 5 measurement points here, but I don't have them. So I just keep 2. Then measurement directions. I can measure it in many directions in each point. I recommend to measure in 2 directions. So we can select either 1, that is vertical, 2, that is vertical and horizontal, and we can also add axial direction to monitor vibration in the axial direction so that it will not increase due to our balancing procedures. I suggest that we keep 2, vertical and horizontal. Why it is needed? It is needed because you may have different stiffness or rigidity of your support structure. So if we decrease vibration in vertical, we should monitor that it will not increase in horizontal. Also, if you have very different vibration levels in 2 directions, then you may have a problem like a resonance. So this is the required setup of the machine. The number of balancing planes, the number of measurement points, and the number of measurement directions. What else we can do here? It is not necessary, but we can assemble a scheme of the machine or a drawing of the machine that will allow us to easily identify the points. So let's do it. We go to 5 and we can assemble a machine here from different parts. Let's look at our machine. We have bearing, we have 2 discs, and we have another bearing, and we have a drive motor. So we can assemble this rotor line. A bearing, and we say that we press the arrow right, and we can select what is it? It is bearing 1. Let's call it bearing 1, a measurement point. Okay, and we add it, button 5, we add it to the shaft line. Then we have a disk. Let's find the disk that we have, like this. We have a disk, and it is plane number 1. So we select that this here we will install the mass, balancing mass number 1. Okay, and we add it. Then we have the same and the same disk, and this will be mass 2. Okay, we add it. And then we have another bearing. Let's find the bearing like this. Yes, bearing like this. And this will be bearing 2. And also we can add it. And by the way, we also have a drive motor. Let's find the drive motor like this. And no measurement points there. We just add it like here. So this is the scheme of our machine, and we will see where we do the measurements. Also, the scheme will go to the report. So we press button 0 to save it. Then we go next. Next is the start of the balancing, and this is button 0. Okay. Initial vibration measurements. So we have to set up what we measure. It will be in millimeters per second. The other choice is millimeters, meters per second square, inches per second, etc. We will balance in millimeters. Rotation speed. I used to do it in hertz. Let's do it in hertz. Detector RMS, peak or peak. The standards, ISO standards, they require RMS measurement. And angle reading direction, with rotation or against rotation. So the other choice is against rotation. I used to do it with rotation. Pay attention that on our machine, during the trial run, I wrote an arrow with the rotation direction. So if I start it goes in this direction, and I just wrote it with a chalk, not to forget what is the rotation direction and what is the phase angle reading direction when I will install the weights on my machine. So this is already set up, and now we can start the measurement. You see that right now it says that bearing number 1 vertical and horizontal. It is automatically assigned to channel A and channel B. So we can just take our sensor and install it in these locations, like this. We can also change it in the vibration analyzer, so you can select any of the measurement point and press 1 or 2. 1 goes to the channel A, like this, and 2 goes to the channel B. So it's like this. But it was automatically assigned the first 2, so I just leave it as it was before. So this is the full setup. Now we can start our machine and make the measurement. So we wait till it stabilizes on the rotation speed, and then we press 9 button. That is do the measurement. So I press 9. The measurement starts. It takes a few seconds to make the readings. What it measures? It measures rotation speed, amplitude and phase. So now we have the rotation speed that was measured in hertz as we selected, and amplitude in vertical 8.4 and in horizontal 2.5 with corresponding phases 49 and 104. So you see that these phases differ more than on 90 degrees. It's quite natural, it could be. The next measurement points are automatically assigned to bearing 2 vertical, channel green one, the A, and bearing 2 horizontal on the second channel. So we take the 2 accelerometers from here, one and the second one, and we install it. Second channel, yellow, first on the corner, then on flat. First on the corner, then on flat. We check it like this, and we go to our data collector and press 9 to make measurements. We press it. So again, a few seconds needed to make amplitude and phase measurements. We have completed the measurements. So these are the amplitudes that we have here, and these are the phases that we have for these measurements. So we can stop our machine And now we go next. Button 0, that is next. So we press it and go next. What it asks? It asks what we do. If we have already balanced this machine and we have influence coefficients, then it will take the influence coefficients and will just calculate us the correction weights. But we are measuring it for the first time, and then so by influence coefficients it means that we have them, and we can enter it manually or take from the database. The full balancing, it means that we will install trial weights and calculate first influence coefficients. We never balance this machine with this data collector, so we select the full balancing and go next. What it says, okay guys, please install the trial weight somewhere and tell me where you install it. So the correction plane, we can select either 1 or 2. Let's select 1. It will be where we install the trial weight. The trial weight, we need to enter the mass, the amount of weight, and the angle on which we install it. So now we should think about two things. First, what will be the amount of trial weight, and another, on what angle we install it. Let's look at our machine. The best choice of the trial weight amount is that we have to look at what masses are already installed on this machine. So here I see that one mass is here, and it is quite big one. Another mass is here, and it is not that big. So I suggest that we take the amount of the largest balancing weight that we see here, or close to the largest. Here I have very many weights, so I have assembled the weight like this. It looks similar, something like this. Okay, then I need to weight it. I switch on the scales, yes, here, and I weight it, like this. So we have 10.6 grams. Okay, we go here, enter, and enter here 10.6 grams. Enter. Okay. Angle. Where we install it? Generally, we can say that you can install it anywhere on the rotor. You can install it anywhere on the rotor. But we have done initial measurement of run in and coast down, actual of coast down, and it showed us the phase of 170 degrees. You can see it in the previous video. So 170 degrees should be from this mark, from the reflective mark that we have on the rotor. So here. So we take with rotation, with this arrow, with rotation, 170 degrees approximately, and 170 degrees approximately. So here we have 20, I think, that degrees. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 20 degrees here. So we do not have 70, we will install on 180. Close to 170 is in between. We can spread it on 2, but this is just a trial run, so we install it on 180. Yes, this is... Actually, no, it is 100... Yes, but it is 180. We fix it, so that it doesn't flow away, like this. Fix it. And we enter it for the data collector. So we say that angle is 180 degrees. Okay. And it asks whether it is temporary or permanent. Temporary, it means that you will not that you will remove it after measurements. Permanent, it means that you will leave it on the rotor. So this one I will remove, and this will be temporary. And okay, we have to go and do the measurements. We select the channels. So now our sensors are installed on the bearing 2. So not to move them, we say that this is channel A and this is channel B. Let's check that we have vertical A, this is a green, so it is vertical, it's okay. So the last is horizontal. We start our machine, do it carefully, like this. When it started, we press 9 to do the measurement. Let's see. We have 5 and 3, and we have sensitivity. So it means that we have sensitivity to our mass, that the vibration changed. Now it suggests to make measurements on the second. So we remove the sensors from here, and we install it on another gearing here, and here, like this. And we press again 9 to make the measurements. 9. You see that we have sensitivity to this mass everywhere. It means that we can now do the calculations. If there was no sensitivity, it will be minus, and usually it means that you have to increase the trial weight, or you can calculate without it. So we had something like 5 or 4.8 millimeters on the first channel, now we have 3. So we have decreased it a little bit. Here we had 5, and I think that now it is also 5. But the phase, it shifted. So now we stop the machine, and we do the calculations. We go next. So 0, it means next. We go, press 0 and go next. It says, okay guys, so it suggests to put another 13 grams on 140 degrees, and this is the vibration that it thinks it will be on this machine. So actually this is a very low vibration levels. 1.5 maybe is the maximum in horizontal on the bearing 2, and this is a good result if we install it. So we can install this weight and actually finish the balancing. If we are not satisfied with this result, what we can do? We can take the next measurement plane and install the second trial mass. But for this machine I see that it is not necessary. You can balance it with one single plane, installing the weights on this location. Another 13 grams on 140 degrees, and the machine will be balanced to 1.5 millimeter. But let's take the next mass. So we select 0 for the next mass, and we have mass 2, and we have to install it somewhere. So let's do the same. We take the same mass, 10.6 gram, maybe install it on a little bit different. It told us 140. We can try to install it on 140. So we remove the mass, the temporary mass that we installed. It is this one. So we unscrew it. And install it 140. So this was 180. So we go to here, and just something like we just move it a little bit on 40 degrees and install it here. And we tell it that we have installed 10.6. We removed it as a temporary and install it here, and select the angle 140. Let's see. Actually I can say that you can install it anywhere, just any mass anywhere on the rotor, and it will work. So now we did like this, and bearing number 1, vertical and horizontal. We have already installed the sensors. The first one is vertical, the green one is vertical. So we can start the machine, do it carefully. I see that the rotation is very minimal. The vibration is very minimal here. So we just press the 9 button to do the measurements. Yeah, you see that we have 0.9 and 0.6 millimeters, and we have sensitivity to this mass also. Now it says that bearing 2, A and B channels, so we remove these sensors. and we put it on the second bearing, like this and like this. Watch the cables, and we press 9, button 9, measure. Again a few seconds to measure rotation speed, amplitude and phase on 2 channels. Yes, we have 2 millimeters per second and 0.9 millimeters per second, 0 phase, and we have positive sensitivity, so everything is okay. We can switch off our machine. So the measurements is good, and we continue. We press the next button, 0. Okay guys, it says that we are in a case that we have equivalent planes. Equivalent planes, it means that both of these two planes, they have similar influence on vibration. And we do not need to do the 2 planes balancing for this machine. We can select only one plane, either of them, and fix only one weight, and in this case the machine will be balanced. In the opposite situation, it can be the case that you, for example, install a big mass here and a big mass on the opposite side of the machine. Actual influence will be on the difference between these two masses, but the big amount of masses, they can tear the rotor. So it is actually recommended to select only one plane. So I suggest that we select the plane number 2, like this, and we will balance it only on plane number 2. Why plane number 2? Because it has higher vibration levels. And in this case it is more reasonable to put the weight here. So okay, we select it and we go next. Now it will calculate us the correction weights. So it suggests that the weight should be 11 grams on 128 degrees on the plane number 2. So we need to apply this weight, and vibration will be minimized to these levels if we do everything very correctly. So it is less than 1 millimeter per second. Let's do it. So we need 11.8 grams approximately. So we take our trial weight away. Our trial weight was here, this one. And instead of this, we need to find the other mass. We need to do 11.8. Let's see what we have here. We have, oops, sorry. Let's wait till it will show us 0. It will auto-calibrate. Yes. And we need, so now we have 10.6. We need another gram. Another gram. Let's find another gram. 12, too much. 11.4. Okay. 11.5, and here 11.78. So I think we will not come closer. Maybe we find some. I think that it's the same. Yes, it's all of them are the same. What about this? Too much. Okay, let's stick with this. So we put 11.5. So if there was no equivalent planes, then it will calculate the 2 masses for both planes. But now we have an equivalent plane, and we don't have to install anything here. So just in this plane. So okay, we take it, and we go to the final measurements. So it will be 9, and it asks if we removed the temporary weights. We say yes, we removed it, and then it says what have you installed. We check this and we enter here 11.5. So we take enter, and use the cursor and say that till 5. And where we install it? Okay, so 0 was here, 0 was here, and we need 130 degrees approximately. So we go here, this will be our 0, and we can draw it. So here is the 0, here is the 0, 10 degrees approximately here, and then we have 20, 40, 60, 80, 100, 120, and 130. So actually here will be 130 degrees with rotation, in the direction of rotation. And we install here our weight. Like here, we install our weight. And we tell it that we install this weight 11.5, and we installed it on 130 degrees like this, and we go and measure. So now we have installed accelerometers on the second shaft, so we will say that we have installed them on the second bearing. Vertical is 1 and horizontal is 2, not to remove the sensors. So we start our machine. We start our machine and we press 9 to make the measurement. The vibration is very minimum. Vibration levels are very minimum on this machine. Yes, you see that we have less than 1 millimeter. We have less than 1 millimeter, and we remove the sensor and put it here. We remove the second sensor and put it here. Cables, channel A, channel B, and press 9 to get the readings. Also, you see that less than 1 millimeter. So we have very good results here. All of them are very good. So it was 5, now it is 0.7. It was 4, now it is 0.4. So in 10 times we decreased the vibration on this machine. Okay, we stop our machine and we go next. Next, it says, okay guys, you can even increase the balance of your machine. You have to install 1 gram at 0 degrees. For this machine it is not possible to install 1 gram, and the vibration levels are quite okay, so we can finish it. Otherwise, we can install 1 gram on 0 degrees and continue to decrease the vibration. But never do the excessive work. This is finished. So we can also look at the scheme of our machine here, for example 5. Yeah, this is the vibration that we have now. The sum of the vibration, the vector sum of the vibration in the second point. Actually, this is not the vibration, this is the masses that it asks to install. It asks to install 0.964 grams on 180 degrees. If we measure vibration, it will show the vibration levels. We go back and we do the finish of our balancing. So button 8 is here. This is the balancing report. So what we have done today, this is what we have measured. The setup of the machine, the scheme of the machine, initial vibration levels, what we installed, the weights that we have installed. This is the trial vibration measurements, and everything that we have done in here in this report. You can print it out. Finally, the influence coefficients. that afterwards you can use for the balancing this machine without any trial runs and without any trial weights. So you can print this report, and this is the finish of the balancing. We go next. It saves the result. Here is this our machine. It is the history of this balancing, including the influence coefficients. So that's it for the balancing. Thank you very much for your attention. Welcome to our channel.